Hello guys, I am Kashyap Gauri from Gujarat. I am pursuing right now BTech in the mechanical engineering final year, and our today's topic is electricity. So electricity is a chapter of chapter 10, chapter 12, class 10. So what do you do when you feel hot? That's the simple question. If we ask that what do you do when you feel hot? Simple answer is we switch on the fan. Isn't that simple? Because we are feeling heat and we want some coolness. That's why we are switching on the fan. So during that, what we do? We switch on the lights, we switch on the lamps, we switch on the bulbs, we switch on the tube lights. Whatever do you say? We on that. Why? Because we feel darkness. And all these appliances are how you can turn on with the help of switch. Just like it is shown in the picture here. Switch. So the basic question is how the switch after owning the switch, the electric current passes to the appliance and the appliances is getting on or getting into the work. What is the reason behind that? Can you explain? Wait, do not confuse, I am here to explain you. So electric current is nothing but the what we can do is the switch from the appliance, the electric current is passes like just like this circuit. When you switch on the light, you switch on the switch, the electric current gets supplies to the appliances and the appliances turn on. And if you push off the switch, the electric supply electric supply gets down and the current does not flow to the appliance and hence it is shut down. But what make does the current, what is the reason that the current from the switch to the appliance goes on? How it is created? How it is generated? This is the basic simple question you can ask. So, if I consider a net Q charge, Q, unit charge Q, particularly on the conductor of cross section time, cross section, let's say of any cross section in the time t. So, what will be the current? Current will be the I. So across the cross section, across the conductor, what will be the current? It is will be the I equal to Q by T as shown in figure. I equal to Q by T, where Q is the unit charge, net charge, and time T is the time. So unit charge per unit time is what? Current I. So the SI unit of electric charge is what? Coulomb. SI unit of electric charge Q. Q's SI unit is what? Coulomb. C, denoted by C. It is as simple as that. Do not confuse. So current flows. Where do the current flows? This is the question again. Where do the current flows? Current flows to the metallic wires, and that is what we call the conductor. And we have already seen in this definition that the cross section of a conductor. So what is conductor? Conductor is the semi ceramics, fine ceramics, or the metals like this is shown in figure. And generally we have seen, might have seen the wires having the insulation, and if we disclose the insulation we get this colored metal, and that metal is called the copper. In Hindi we can say tamba, copper. Copper is used in the conductor for making the conductor. So what is the SI unit of current? SI unit of current is simple. You can say from these options, which is the SI unit of current? It is ampere. A green color box. What? It is the ampere A. So what makes the electric charge to flow? We already know that the electric charges flows from the switch to the appliance. But why do the electric charge flow? How do the electric charge flow? What is the reason behind that? And if we can tell out the reason to anybody, then we can say that we have covered the electricity chapter. So this is the big question. So, if we consider the water kept in the storage tank at the height, at this much height, if we kept the water, if I put, if I have to put down the water from the tank, so I will make a hole. So how the water will be passes through the hole, or how the water will come downward? How the water will come downward? Because of the pressure difference, because of the gravity we know. Okay, because of the gravity and the potential difference, the water will be coming out into the ground. This is the H, this is the H2. So water will be coming down and going to the home. We have seen in the water rainwater harvesting and just like that. It is as simple as that. Okay. Similarly, there is the difference between the in the conductor at the two ends. One hand having the less potential and the other hand having the higher potential. So the charges will go around from the higher potential to the lower potential to satisfy the condition, to make the equilibrium state. So what it is called as? It is called as the potential difference, not pressure difference, not gravitational difference, not height difference, as it was in the case of potential energy. It is the potential difference that passes through the conductor and that makes the electric charges flow. Okay, this is as simple as that. If we consider, if I consider that I have energy, I have more energy than you. So what will I do? I will pass the energy to you because I have more energy. You have less energy. So naturally, the high energy will be given to the lower energy. So what is happening here? It is also the same procedure. It is also the same process. Potential difference is nothing but the energy difference. On the one side, the energy is higher, and the other side, the energy is lower, and that is why the current flows. Is that is why the current is flowing. So what is the assignment of potential difference? What is the assignment of potential difference? It is volt, V, denoted by V, volt, showing in the meter. You can see volts, dt, DC current. So potential difference is what? Potential between 2 points is what? W by Q. Okay, V is equal to W by Q. So have you seen? Okay, have you ever seen the speed breakers on the road? Have you ever seen the speed breaker on the road just like that? So your answer will be definitely yes. When we move through the roads, these speed breakers, what does these speed breakers do? These speed breakers are doing the same. It provides the friction, it provides the resistance, it reduces our speed of vehicle because it creates the friction or it creates the barrier to the vehicle or to the bicycle we are riding. So what does this speed breaker do? It creates the resistance to wheel, to the wheels. So what they do? They do this. They reduce the speed on the ongoing traffic to maintain the traffic. That is why the speed breakers are placed. So in the same way, the resistance is there in the flowing of current and the flowing of charges. And this resistance is known as the electrical resistance, not the frictional resistance as in case of the roads, but it is known as the electrical resistance, and that SI unit is ohm and it is symbolized by omega. This symbol is known as omega. Do not confuse. The symbol is known as omega. So what is resistance? It is the V upon I. V upon I. V is what? Say. V is what? V is the voltage. V is the volts. Okay, potential difference. Voltage or potential difference is just the same thing. Do not confuse. And I is the current. I is what? Current. Okay, so resistance is what? V upon I. Now, you have might a question that why does the resistance exist? Why it is necessary for the resistance and why it is there in the conductor? So, first, why is reason? There are simple parameters we can take into the consideration. First is length. So what is, if resistance increases with the length increase, as the length will increase of the, as the conductor length increases, the resistance get increase. If this much length is there, the resistance will be lower. If I increase the length towards that much, towards like this, if I extend the conductor, then the resistance is again increase. If I extend toward the this, again increase, again increase, and goes on. And if I reduce the length, if I compresses the length, then what will be the resistance will be lower. Okay, so resistance is directly proportional to length, but it is inversely proportional to the thickness. Another parameter is what? Thickness or the area of the cross section. So if the thickness is higher, if the thickness is increasing, the resistance decrease, because there will be the more area to passing the charges. There will be more area to pass the charge easily. It is as simple as that. Okay, like if you consider like you have the narrower path. Okay, you have the narrower path. If you want to cross the lane, if you are walking in the lane and the path is narrower, so your resistance will be higher. Okay, resistance will be higher because you won't cross in a single minute. You have to take time. It will take time to cross the lane because it is the narrower. If I am on the highway, then what will you do? The vehicle will passes through the speed. So that same concept is applying here. If we increase the thickness of the conductor, if we increase the thickness of the conductor, or if we increase the area, the resistance decreases. Okay, so resistance is inversely proportional to the area. Remember this thing, directly proportional to the length and inversely proportional to the area. Okay, third point is material of the wire. Okay, so resistance depends on the material of the conductor. Like if we see aluminum is lesser or the less good conductor of electricity than the copper. Copper is more efficient than the aluminum, and that is why we use the copper in most of the places in the applications. Aluminum is also usable, but right now we are using the copper much, as in the market we can see. So it depends on the material. If we take silver, it is the or it the resistance is less, and it is the good conductor of electricity. So conductor of electricity is defined from what? Conductor of electricity is defined from this, that whatever the resistance, if the resistance is lower, then it is the good conductor of electricity. If the resistance is higher, then it is the good conductor of electricity. It's as simple as that. Okay, so how to calculate the resistance of the conductor given it in by length or the cross section? How to calculate that? So as already I have told, resistance R is proportional to L, but inversely proportional to A. So this is what we have put here. The values are putting here are proportional to L, inversely proportional to A. So if we want to reduce the proportionality, we have to make a constant, and that is rho. R equal to rho L by A. Okay, so this is the equation. What is rho? Rho is the constant of proportionality, and it's called the resistivity of the material. Greater the resistivity, greater the resistance. Okay, it is what? Rho. Resistivity of the material. Any material have the specific resistivity. So, can you name the least resistive material? Okay, least resistive material, which having the least resistivity. Do you know how the traditional light, how the light bulb, how the light bulbs, these yellow light bulbs emit light? Do you know? These bulbs consist of tungsten. If you if you ever have seen this W type filament in the bulb, We are already seeing, and we are wondering that what is this W-type filament? This is made of the tungsten metal, and it has a high resistivity when the current flows through it. So when we switch on the bulb, the current will flow through it to the tungsten metal, and the bulb will light on. Okay, because of the high resistivity. So consider a simple circuit like if we have battery, okay, to make the voltage difference. So it is fuse or switch, and this is the voltmeter to measure the voltage or potential difference, and this is the LED, and this is the current measuring device ammeter. This is the simple circuit, general circuit. Battery to create the potential difference, fuse or switch, voltmeter to measure the voltage, and the ammeter to measure the current. Okay, now measure the voltage across the resistor. Okay, measure the voltage across the resistor and the current in the circuit. We have to measure it. So now add more two resistors. If we add two resistors in the given two different situations, again you have to measure the voltage. So if we are making this type of series connection, okay, r1 r2 r3, these are what resistors in series. Situation 1, like this is one arrangement in the series, side by side. If we are making the resistors, then it is called the series arrangement. And you will observe that the current remains same throughout the whole circuit. Okay, current is remaining same throughout the whole circuit. Okay, current is remaining same. Potential difference is what? It is equal to the sum of V1, V2 and V3. Okay, resistor 1 having the V1, resistor 2 having the V2, and resistor 3 having the V3. So voltage difference will be what? V will be what? V1 plus V2 plus V3. Okay, okay, understood? What did we learn? Joined in series, the resistance of the combination Rs is equal to the sum of the individual resistance. Means resistance will be what? R1 plus R2 plus R3. It is as simple as that. Okay, all the resistance will be what? It will be R1 plus R2 plus R3. As simple as that. Situation 2. Now if we consider the parallel arrangement. Like if I am placing the resistors parallel to the adjacent to the one another, parallel, not crossing each other. So this type of arrangement is known as series arrangement, parallel series. Oh, okay, sorry, but parallel resistors. So here, what will you observe? That the voltage remains same across the all the circuit. If you see that the voltage is same to the one endpoint to the another endpoint, voltage is same. Okay, what is changing? What is changing? Total current is the sum of the separate currents. Yeah, understood. Total current is separate like I1, I2, I3. Okay, after passing through the resistors, I1, I2 and I3. So what will be the here? It will be the I1 plus I2 plus I3 total current. Okay, so do not get confused. Once again we can repeat in the series. Okay, in the series what is happening? V1 plus V1 plus V2 plus V3, and then parallel I1 plus I2 plus I3. Okay, so what did we learn? We can conclude that the reciprocal or the equivalent resistance of the group in parallel is equal to the sum of the reciprocal of the individual resistance, like this. It is shown in the equation. 1 upon r rho, sorry, 1 upon rp is equal to 1 upon r1 plus 1 upon r2 plus 1 upon r3, because it is directly proportional. It is r1 plus r2 plus r3. So we can also write this in this form. 1 upon rp is equal to 1 upon r1 plus 1 upon r2 plus 1 upon r3. Okay, so do you bath in hot or cold water? We always take the baths. We also know. We always bath regularly. So in winter we take bath with the hot water, and in the summer we are taking the bath with the cold water. Okay, this is hot water. And see, this children or this kid is feeling what? Hotness. Like his skin is getting dimmed or getting tanned as for the hot water. So, how do you feel the heat? How do you feel the heat? Okay, how do you feel the heat? So, how do you feel the heat? Everyone is using the electric geyser. Everyone is using the electric geyser for converting the cold water or the room temperature water into the hot water. We are converting the we are using the geyser. We have that geyser in the home. So how does the water get heated inside the geyser? That is a simple question. What what does the process is inside the heater or inside the geyser that heating the water? What is the process? So there is the high resistance rod, or we can say the high resistivity material is using. Okay, from which the electricity is flowing through it, and which electricity is turning the heat, and it heats the water. It is heating the water. Do you remember this example? Do you remember this example? Even inside the kind of bulb, this is what it is happening. It is the same thing. Electricity is used to heat the filament to produce light. Okay, electricity is doing what? Electricity is nothing. Current is nothing but doing the heating the filament. It heats the filament, tungsten filament, W type filament to produce the light. Okay, can you state some more example like this? Like we have taken the example of the electric geyser, electric bulb. Have you any heating instrument? Okay, remember in your mind. And what is now the electric power? Yeah, right. What is the electric power? So power is what? Rate of doing what? Like in what time? In what time? What amount of work are you are doing is power? Is your power? Okay, you are doing the work in 1 minute. If you are doing work in 0 0.5 seconds, if you are doing work in 1 second, then your power will be increasing because rate of doing work is increasing. Okay, work per unit time. So power is also the rate of consumption of energy. Power is what? How much energy do you consume? It is also known as the power. Okay, so power is what? Power is also known as the VI. P is equal to VI. Okay, VI. V is what? Voltage. Already we have seen. Do not get confused. Remember that particular slide. V is what? Voltage, and I is current. So V is what? In the place of V, I can write the IR. V equal to IR. We have already seen the equation. If you remember this equation, let we can say, let's summarize that. This equation, if I take the I this side, so V will be what? V equal to IR. So this equation or this value is used here. This value is used here. Okay, so I into I will be I square, so it will be P is equal to I square R. So P will be what? V square divided by R. Okay, V square divided by R. V square, why V square divided by R? We are doing nothing, but we already know V is what? IR, and it is I square. So we can write V square, and R is already there. If we divided it by R, then this will be the equation. Okay, we are creating the another form. Do not get confused. First, we have putting the V equal to IR, and then IR equal to V. That is why V square upon R. Okay, so power is unit is what? Watt. Power SI into power is what? Watt. W. Big W. Watt. Okay. So, do you know how the electricity bill is calculated for your home consumption? If you have seen that your electricity bill might be 2000, 3000, 4000, 5000, 6000, according to the appliances you are using. Okay, so how it is calculated? How it is the electricity bill is calculated? Okay, the unit watt is very small. Okay, unit watt is very small. In actual practice, the larger unit is used, which is called the kilowatt. It is just same. Do not get confused. I am explaining. It is just same. Like if you go to the vegetable market, what you are saying? Give me the 1 kilo bananas, 1 kilograms of bananas. You are not saying that 1000 grams of bananas. Give me the 1000 gram. Why? Because we are addicted to that. 1 kilogram, 2 kilogram, 3 kilogram. It is nothing but the 1000 gram is equal to 1 kg. We have already know. So this is what it is also the same thing. Kilowatt, 1 kilowatt means what? 1000 watt. Okay, 1 kilowatt means what? 1000 watt. It is just same as the mass. Kilogram equal to 1000 gram. Okay. So since the electricity bill is what? This is product of power and time. So how much power you are using in unit time? How much power you are using in time, particular time, and that will give the energy. And then according to the energy, we are waiting. We are getting weighted or we are getting paid. Okay. So the commercial unit of electricity is what? Kilowatt. Kilowatt hour. Hour is what? Time. So kWh you will always see, or if you might have not seen that. So after this session, you can see the meter in your home. If you will say to your parents will be letting you to know that it will be kWh. It will be written like this, kWh. But do not go more nearer to the meter. I am just saying to just look it out that what is written there. Okay, kWh. So commonly used, it is denoted as unit. What is kWh? It is known as unit. So 1 kWh is what? 1000 watt into the 3600 second. It is as simple. 1 kilowatt is what? 1000 watt. I have already told. Hour is what? Hour we can convert into the second. So it will be 60 second or 60 minute. 1 hour means what? 60 minute. And 1 minute is what? 60 second. So 60 into 60 it will be the 3600 seconds. Okay. So we can write it like this: 3.6 into 10 raised to 6 watt second. And this watt second is what? Joule. Watt into second is what? Joule. We can denote it as Joule J. Okay, now check the power usage of your TV that you use. Okay, actually, and calculate the bill you might get for the TV for the 5 hours daily. If you are using the 5 hours daily, the TV, so what will be the calculation? Okay, what will be the calculation? Just do it out. It is your homework and it is for your clearing the concept. Thank you. Bye bye. Good night.